Hello, Chemistry Level 2 Structure Bonding 2013 paper. Here, boron and phosphorus are both bond with 3 fluorine atoms to form BF3 and PF3. However, the molecules have different shapes and bond angles. Pictures of them. Explain why these molecules have different shapes and bond angles. In your answer, you need to include the shapes, the factors that determine the shape, approximate bond angle, and justification of why you chose the bond angles for each molecule. So, I'll use this as my planning and then this side as where to write my answer. I have BF3 and PF3. The shape of BF3 is trigonal planar. So planar. And then my shape for phosphorus trichloride is trigonal pyramid. Trigonal pyramidal. The bond angle here will be nearly 120 degrees, roughly, and this one here will be 109.5 degrees, roughly. So if you don't include the 0.5, that's fine. Anything else we need to mention? So, justification. This can be part of my answer over here. So, let's do BF3 first. So, BF3 has 3 areas of negative charge. So, see here, 3 areas of negative charge. Around the central atom. These repel for maximum separation. You have to mention these repel for maximum separation, or else that will cost you points. So, these areas are all bonding regions, giving this molecule a trigonal planar shape with a bond angle, or with bond angles of 120 degrees. Okay, so I've given the shape, I've given the factors that determine the shape, namely that it's got 3 areas of negative charge and these areas are all bonding regions. I've given the approximate bond angle and I've justified it with the fact that all the areas are bonding. Let's do the same now for phosphorus trichloride. So PF3 has 4 areas of negative charge around the central atom. These repel for maximum separation. These areas, notice I'm just using the same sentence as above, but then changing the specifics. So these areas are that doesn't work, does it? 3 of these areas are bonding and 1 is not a lone pair. One is non-bonding, a lone pair. This gives PF3 an underlying shape of tetrahedral. But because of the lone pair, its actual shape is trigonal pyramidal, or pyramid, with an approximate bond angle of 109 degrees. Now, if I look at my marking schedule, here I have trigonal planar, 120% bond angles, trigonal pyramidal, roughly 109.5 degrees, 109 will be accepted. Shape is determined by the number of regions of electron density, electron clouds, whether they are bonding or non-bonding. So that's a general statement. BF3 has 3 regions of electron density. There's 3 areas of negative charge, same thing. Electron clouds around the central boron atom. The regions of electrons are arranged as far apart as possible from each other to minimize repulsion. Repel for maximum separation. Which results in trigonal planar arrangement with a bond angle of 120 degrees. All 3 regions of electrons are bonding, so the overall shape is trigonal planar. That's what I've put here. These areas are all bonding regions, giving this molecule a trigonal planar shape with bond angle of 120 degrees. And then the same here, PF4, phosphorus trichloride has 4 regions of electron density. These regions of electrons make a tetrahedral arrangement with a bond angle of 109 degrees. Only 3 regions of electrons are bonding and 1 is non-bonding, so the overall shape is trigonal pyramidal. The non-bonding electrons have increased repulsion, therefore decreasing the bond angle to less than 109 degrees, 109.5 degrees. What you need here for excellence is in the arrangement of electron density, the electron clouds around the central atom used to explain shapes and angles of the molecules includes a comparison of the different shape and bond angles. They don't have a comparison in their model answers. Either way, this would be an excellence answer. To get a merit, you had in the arrangement of electrons around the central atom is used to explain shape. So if I hadn't included my bond angle and had just done my shape, that would have given me merit. And for achieved, I would need 2 Lewis structures here. I would need 2 shapes correct, and I would need the two bond angles correct. So those are all achieved criteria. So this page here is my achieved. This page here gets me up to excellence.